There's one interesting fact about quantum mechanics which makes it different from Newtonian mechanics. It's counterintuitive. The fundamental concepts of classical mechanics, such as force, acceleration, or trajectory, can be intuitively understood. It's not difficult to imagine the behavior of a classical system in various situations. While crossing the road, we intuitively estimate the speed of the car, its distance from us, and the time needed to cross that distance. And while driving, we have to take into account and estimate many other factors simultaneously. All of this happens automatically. In fact, our brain performs many calculations of classical mechanics subconsciously. For example, just to keep the balance on two legs, our brain processes information coming from millions of neurons of the sense organs in real time and transmits control signals to hundreds of muscles. All of this is the result of the evolution and natural selection. These skills were necessary for hunting, survival, and reproduction. The genius of Newton made it possible to realize and express these intuitive laws in the language of mathematics. Mathematics in this sense is a substitute for intuition. There are not so many non-intuitive phenomena in classical mechanics. Usually they are related to something that is rarely found in natural environment and for which intuition was not developed. But even a child can understand all of them after a more detailed explanation with elementary math. Intuition also begins to fail when we consider things that are inaccessible to our senses. All standard units of measure, a second, a kilogram, a meter, are historically associated with the anatomy of the human body. We can easily estimate them. That's why they are so convenient and familiar for us. But when deviating to bigger or smaller numbers, intuition begins to fail. For example, the fact that the movement of planets and stars obeys the same Newtonian laws is somewhat unintuitive. Through all the years of evolution, in our everyday life we have not encountered such massive bodies continuously moving for billions of years. But as soon as we get into the range of values where Newtonian mechanics is not applicable anymore, intuition simply stops working. A human being has never moved at speeds of even 1% of the speed of light, so we have no intuition for such velocities. As a result, we have a non-intuitive special theory of relativity. The human eye is not able to see the atoms. In the process of evolution, there was no need to develop intuition for the behavior of molecules. The human brain is not able to imagine and intuitively understand the world of elementary particles. So when we encounter very small distances, we have non-intuitive quantum mechanics. The problem with intuition can only be solved by mathematics. Unfortunately, quantum mechanics cannot be understood by watching popular science videos with beautiful animations. Any classical analogies our brain can understand and visualize are simply misleading and wrong. Only mathematics allows us to take a look at this mysterious world. This is partly the reason why our brain resists to accept the quantum mechanics. It deals with such abstract objects that seem to have no relation to the real physical world. For example, what do complex numbers have to do with reality? We do not see any imaginary units around us, but quantum mechanics is impossible without them. On the other hand, intuitive things like trajectories are completely absent in quantum mechanics. Elementary particles do not move along particular paths. Usually it's not difficult to accept and intuitively understand the Newtonian postulates. The acceleration is proportional to the applied force. It's annoying that we cannot intuitively understand not only the conclusions but even the postulates of quantum mechanics. However, they lead to the consequences confirmed by experiments, the most precise experiments ever done. And this has to be taken into account. Classical mechanics is a result of quantum mechanics, but not vice versa. Quantum mechanics describes the world around us more accurately. However, this world is inaccessible to our senses and even imagination. Therefore, quantum mechanics inevitably raises some philosophical questions. This is the reason for many attempts to interpret it, to give a more convenient representation for our imagination. Quantum mechanics is one of the few theories that can shock and even change the worldview. It's surely worth spending a little time to study it. Unfortunately, it is impossible to do without math. Luckily, the mathematics of quantum mechanics is not so hard. Almost everything we need is just the school math.